Making the side parts. To make a clamp, first of all, we need a metal tube. I used a 25 by 25 millimeter tube. Measure 2 pieces of 10 to 13 centimeters from the edge of the tube. After that, cut it off in any available way. Be sure to clean and remove all the burrs that have formed. Do not neglect or skip this step, because metal burrs can very easily cut your hands and cause trouble. After processing, take the first piece of tube, step back from the edge by the width of the ruler, and make a mark. Then make a longitudinal mark exactly in the middle of the tube. Repeat this operation for the opposite side. At the intersection of the marks, punch the recess and drill a through hole with a diameter of 11 to 12 millimeters. The clamping screw will pass through this hole. After drilling, step back 10 millimeters from the edge and make marks on both sides of the ruler. Then also put a longitudinal mark in the middle of the tube. Punch the recesses along the longitudinal mark at a distance of 5 millimeters from each other. Now drill 2 sides of the tube first with a thin drill. In such cases, I usually use a 2 millimeter drill. Afterwards, enlarge the drilled holes to 5 millimeters. After drilling, ream the holes with files to get 1 rectangular hole on 2 pieces of tube. Making a pressure heel. Take a piece of hardwood 5 to 7 millimeters thick and mark a rectangle on it about 2.5 by 6 centimeters. On the central axis, put 2 marks for further drilling. Make conical recesses with a countersink. Drill the wood with a 4 to 5 millimeter drill. Take the second piece of tube, without a round hole, and attach a piece of wood to it. Through the holes in the wood, mark the locations of the holes on the tube. For greater aesthetics, some sides of the rectangle can be rounded. Cut out the rectangle with a hand jigsaw or a fine-tooth saw. Sand the cut piece. Apply scratches to the side with conical holes for better adhesion of the glue. Drill one side of the tube with a thin drill bit. The clamping heel will be attached to these holes. Making a jumper. Measure the exact width of the rectangular holes in the 2 pieces of tube. Cut a 5 millimeter thick strip of metal to make a jumper. The width of the jumper should be 5 millimeters larger than the width of the rectangular holes in the tube. The length of the jumper can vary between 15 to 20 centimeters. Place a piece of tube on the edge of the jumper and make a mark. Then remove the tube, step back another 3 to 5 millimeters, and draw a perpendicular. Place a ruler in the middle of the jumper and make 2 longitudinal marks on each side of the ruler. The sections of the jumper marked in black need to be removed to get a semblance of a tenon for carpentry joints. The marked sections can be removed with a file, angle grinder, or belt grinder. At this stage, it is important not to remove too much from the jumper. As you approach the marking lines, I recommend periodically placing a piece of tube against the jumper and trying to push it onto the tenon. If you do not do this, you may not notice how you make the tenon too narrow. In this way, form tenons on each side of the jumper. Transfer the dimensions of the rectangular holes to the side of each piece of tube. Within these dimensions, make two marks 10 to 12 millimeters apart. Drill one side of the tube with a thin drill bit. Insert the jumper into the rectangular hole of the tube. Drill the jumper and the opposite side of each tube with thin drill bit. Take a thick nail from which you will then make rivets. Measure the thickness of the nail and select a drill of the same diameter. Use a nail drill bit to drill through two pieces of tube and the jumper. In my case, it is 4 millimeters. If your drill is slightly thinner than the nail, cut off its head and insert the nail into the drill chuck. Then wrap the nail with fine sandpaper and turn on the drill. This grinding will reduce the nail slightly to the desired thickness. Then insert the jumper into the tube and hammer the nail into the hole. Cut off the excess parts of the nail, leaving 2 to 3 millimeters on each side of the tube. Then hammer the nail into the second hole and cut off the excess. Rivet the protruding parts of the nail on each side of the tube. Excess rivets can be removed with a file. Don't remove it completely, so that the rivets don't fall out of the tube. Repeat the same operations for the second piece of tube. Making a built-in nut. Measure the inside size of the tube and transfer it to a piece of thick metal. Measure the distance of the round hole in the tube, reduce the distance by 1 centimeter, and also transfer it to a piece of thick metal. Drill the metal with a thin drill bit. Then increase the hole to 9 millimeters. Make 2 more marks and drill holes for thin nails. In the large hole of the metal, cut a thread with a diameter of 10 millimeters. Cut out a rectangle of 21 by 50 millimeters from the metal. The smaller side of the rectangle should not be larger than the inner dimension of the tube. Then take a piece of hardwood and drill a hole of 11 to 12 millimeters. The total thickness of the wood with the nut should also not exceed the inner dimension of the tube. Place your rectangular nut on top. Insert nails into the small holes of the nut and give it a few light hammer blows. Then remove the nut with the nails and drill holes of the same thickness as the nails at the marked points. Nail the nut to the wood. Cut off the excess parts of the nails and file the remains. Cut the wood around the entire perimeter of the nut. As a result, such a sandwich should easily fit inside the tube. Clamping screw. Take a long metal threaded stud with a diameter of 10 millimeters. Cut off 15 centimeters. It is important to note, in order for your clamp to be able to screw in completely, the length of the stud should be longer. I intentionally cut it off less because I don't need to screw the clamp completely. I'll explain why at the end of the video. Step back from the first edge of the stud, 15 to 20 millimeters, and cut the thread. Drill the stud with a 4 to 4.5 millimeter drill. Take an extended nut with the same thread diameter. Drill the nut with a 3 to 3.5 millimeter drill. Screw the nut onto the screw and synchronize the holes. Hammer a nail of a suitable diameter into the hole. Bite off or cut off excess parts of the nail. Clean the remains with a file. This side of the threaded stud will be inserted into the wooden handle of the clamp. Making a screw handle. Take a piece of hardwood and saw off a piece of approximately 10 by 3 by 4 centimeters. If the piece is uneven, plane it to get a smooth parallelepiped. On the wide side of the parallelepiped, place a nut with the same diameter as your threaded stud and trace the nut around the perimeter. Drill a blind hole in the wood. Finish the hole with a chisel to get a hexagon. Periodically insert an enlarged nut with a screw to check the dimensions of the hole. Cut off the excess thread. Take a thin piece of hardwood and trace the dimensions of the parallelepiped on it. In the center, drill a hole of 11 to 12 millimeters. Make scratches for better adhesion of the glue. Insert a nut with a screw into the parallelepiped and glue it with a thin piece of wood. After the glue dries, cut off about 2 centimeters of thread on the other end of the stud. Step back 3 to 5 millimeters from the edge and put 2 marks at a distance of 10 to 12 millimeters from each other. Screw 3 nuts tightly onto the stud. It is important that one of the faces of the central nut is located strictly above the second mark, and the remaining nuts are tightened and adjusted to the central one. Drill through the central nut and threaded stud with a 3 or 4 millimeter drill bit. Unscrew all the nuts and drill the threaded stud at the first mark. To this end of the stud, a special pressure circle will be attached, which will contact the object that needs to be clamped. Trim off excess glued wood. Give the handle a comfortable shape. You can use rasps, chisels, a grinder, or an angle grinder for this. Making a pressure circle. Take an enlarged washer with a 10 millimeter hole. Punch 4 holes closer to the outer diameter of the washer. Use a thin drill to drill the washer in 4 places. Then take a piece of paper tape. Put the drilled washer on its sticky side. Put 3 more enlarged washers with a 12 millimeter hole on top of it. Synchronize the holes of all the washers and cover them with tape. Clamp the washers with pliers and drill through the entire kit. Insert nails into the drilled holes. Do not open the pliers until you have inserted at least 2 nails. When you have inserted all 4 nails, remove the tape. Cut off the excess nails with nippers and rivet the rest with a hammer. The end result should look like this. Now take 1 rivet with a shank thickness of 3 millimeters. Remove the rod from the rivet, place it in the washer, and measure the exact size of the hole on the rod. Cut the marked piece off the rod to make a pin for the threaded stud. So, to fix the clamping circle, you will need a cotter pin, a nut with a drilled hole, 2 regular washers, the clamping circle itself, and a pin. Time for some preliminary assembly. Insert the rectangular nut into the tube and align the holes. Tighten the screw into the tube about halfway. Tighten the nut onto the screw. Put on 2 regular washers. Then put on the pressure circle with the smaller washer first. Insert the pin into the first hole in the screw. Pull the pressure circle to the end of the threaded stud. At this point, the end of the stud and the pin should be recessed into the hole of the clamping circle and not extend beyond its plane. If this does not happen, the pressure wheel washers are too thin. Gently holding the plate so that the pin does not fall out, tighten the nut as close to the pressure circle as possible and align the holes. Insert the cotter pin into the nut and spread it. Now screw the wooden pressure heel. Here is where I want to remind you about the length of the threaded stud. The stud is almost screwed in all the way, but the clamp is not yet closed and a so-called dead zone is formed. Part of the dead zone will go to the thickness of the tabletop. Another part will go to the thickness of the timber or board being pressed. If you want the clamp to be able to close completely, the length of the screw should be 5 to 6 centimeters longer than the jumper. First, practical test. Good enough. Painting time. I apply metal primer. Priming result. I decided to paint the jumper in my favorite metallic gray. I temporarily cover the painted parts so as not to splash them during further painting. Matte black paint was chosen for painting the square tubes. I decided to cover the wooden parts with red stain. After complete drying, the clamp can be finally assembled. It was time to finish the clamping heel and glue the rubber pad. A layer of contact glue and let it dry. While the glue dries, I screw the clamping heel to the clamp. Heating the glue with hot air to activate it. For the best possible gluing, I need to press the materials tightly against each other. After an hour, the excess rubber can be cut off. The idea is that the rubber layer will better contact the tabletop and reduce the likelihood of the clamp slipping. To make it look nicer, the holes in the pipes should be covered with plastic plugs. In places where rivets are driven in, the plugs should be trimmed a little. Finally, after all the work done, we have such a worthy, as I think, result. Using this technology, you can make yourself a reliable, high-quality clamp even without a welding machine. And that's all for me. If this video was useful for you, put your thumb up, subscribe to the channel, and share this video with your friends. Thank you for watching.